Well, with that, maybe we'll hand it over to Virginia and Cathy to review the paleo database and its application. This kind of grew out of and leveraging some of the funds that Cathy and her long-term research in paleoclimate and some of the 2012 foundational science areas. And I'm happy that it's rolling in to actually inform some of the projects with the whitebark pine and possibly others, so it'll be interesting. We've got people from the Southwest Colorado adaptation project on the line, Nina, Renee, and then we got staff that are working on that as well to see how it can fold in. So why don't I hand it over to you guys and let you tell us about the database and its application.
Thanks, Jeff. Hi, everybody. We are with funding from the first year, we were asked to sort of assemble all of the paleoclimate, paleo-environmental data that are available for the North Central region, and this comes from a variety of sources, as you'll see, and put them into one place in a way that would be easy for people to access. So there's various users of such a database. One are the scientists, and the data still are very technical, so it's not easy for someone with absolutely no training to get to them or to understand them maybe. But then we also would like the database to be usable by non-specialists as well. And it's a great resource. I think it's going to be used by a lot of people interested in historical records, and there's a lot more that we can do with it. So we thought we'd give you information on what it looks like now and take your questions. And if we have time, we'll see how it goes. I can show you how we're using it to study whitebark pine. So I'm going to turn this over to Virginia Iglesias. Virginia's been working on this database as a postdoc that's been funded by the North Central Climate Science Center.
Good morning, everyone. This is Virginia. Thanks for being here this morning. Traditionally, paleoenvironmental data have been used to reconstruct vegetation at specific sites, climate, such as climate variables such as precipitation, temperature, and even ENSO and PDO. More recently, because of advances in data techniques, as well as better understanding of proxy records, we've been able to test hypotheses regarding the ecology and biogeography of species, as well as the relative influence of climate and humans on environmental dynamics. Furthermore, these days, the environmental data are becoming quite popular amongst managers as policymakers, as we can see in the title at the bottom of the page. So even though the past does not provide a prescriptive guide for the future, it helps us understand the natural variability of different systems and provides a context for trends in climate that we are observing today. There is a wealth of paleoenvironmental data for the U.S. However, most of it is available, and when available in databases, it's really hard to find and to access. So that was the original motivation for putting together the database. We ended up collecting almost 1,300 records. We have here in the middle of the slide, you can see 15 different proxies. Some of them are proxies of fauna, vegetation, or climate, and fire. So here in the panel in the left, you can see the length of each proxy. And on the right, we can see the median resolution of the respective proxies. So in general, most proxies are very long. They can be up to 30,000 years old. Some are shorter. However, these shorter ones that span not thousands of years, but centuries, have a high resolution. In the case of tree rings, for instance, which allow reconstructing temperature, precipitation, or snowpack in most cases. As we said, they span hundreds of years, and they can have a yearly resolution. This variety in length and resolution allows testing different hypotheses regarding ecosystem dynamics and climate. So here, let's take It'll take 1 second to load. So this is the database. Each point here corresponds to one data set. As we said, we have almost 1,300. We click in any of them. We can access the metadata that we collected for each site. Because we wanted the database to be a tool for scientists as well as for the general public and also a tool for teaching, we collected more database than is suggested in standard protocols. We'll go over the metadata in the next slide. So here we have an example. Excuse me. This is a pollen record from Yellowstone National Park. The kind of metadata we collected includes some basic information about the site, such as the site name, the state where it came from, site ID, that's an individual name that we assign to each individual data set, and the core number. In some cases, we have several cores from one site. Then we also collected geographical information, such as latitude, longitude, and elevation. Then information about the data, that is, data type, in this case pollen, which is a proxy of vegetation. More information about the site, in this case, Signet Lake Fen, which is our site, is located in a pine forest. Vegetation type, in a more general way, is forest. We have the name of the person who submitted the data, Cathy. We do have a chronology for this site, so that means that meta-analysis is possible, so we have a yes to chronology. This database is also available, this data set, is also available in a different database, which is called Neotoma. And the parameters measured were pollen counts. So if we click here, we can access the data themselves. So here in this PDF, we can see a pollen diagram. A pollen diagram consists of different species plotted on the x-axis. Pollen data are often expressed as percentages. So the x-axis represents pollen percentage for each taxa, pine, poaceae, artemisia, and so forth, expressed as a function of time. What this pollen diagram suggests is that there was a transition, so between 25,000 years ago and approximately 13,000, the ecosystem was dominated by sagebrush and grass, and approximately 13,000 years ago, pine arrived in the area, expanded, populations became established, and they became the dominant taxa in the area, and not much changed afterwards. These data, so this is a pollen diagram that is in the form of a PDF that can be accessed in the database, but in case somebody wanted to do some sort of reanalysis or meta-analysis, the raw data are also available. That is, all the pollen types that were identified in the site, and as a function of depth and time. So here we have chronology number 1 and chronology number 2. We have this data because the way that pollen data are obtained is one goes to a lake or a fen, takes the sediment core, and then takes samples from different levels. From each of these samples, different pollen types are identified, are counted, and then converted to pollen percentages. So the raw data are pollen counts as a function of depth. However, nobody's really interested in knowing how pollen percentages change in depth, but we want to see how these things changed in time. So to do that, one takes samples from the core and submits them for radiocarbon analysis. These samples are dated. In this case, that's metadata that we collected. So, age control, these people submitted 6 radiocarbon dates. They knew the age of the top of the core, that is the year when the core was collected, and they used 2 ash layers corresponding to the eruptions of Mazama and Glacier Peak because the ages of those eruptions are known and they could clearly identify those layers in their cores. So what they had so far was 1 date plus 6 plus 2, that's 9 dates for their core. However, based on these dates, they wanted to assign an age for each single depth. So they fitted a model, in this case a polynomial, to their data. So here they are showing depth from 0 centimeters to 600 centimeters. That's the total length of their core. Here in blue, we can see the 9 dates, the radiocarbon dates that they have, showing the mean, and the bars show the standard deviation, and the model that interpolates their data so as to assign an age to every single depth. We have, for each individual data set, we have a radiocarbon chronology in the form of a diagram, as well as the raw data. However, there is not a one-to-one correspondence between radiocarbon ages and calendar ages. For this reason, radiocarbon ages usually get calibrated. We also provide that kind of information in the database, and we can access that by clicking here. So here we're seeing depth and the calibrated ages. So these originally were radiocarbon ages, which were calibrated, and a model that assigns a calibrated age to each individual depth. These data are also available as a CBS file that can be manipulated for meta-analysis. In addition to these quite specific data, we also have a measurement of, we wanted to somehow express how well dated each record was. So we report the number of years between 2 radiocarbon years, in this case 3,000. In the past, people used to submit only 1 sample for radiocarbon analysis per site, so that would give 1 radiocarbon sample per 10,000 years or 15,000 years, which is pretty low, whereas in this case, they submitted 1 radiocarbon sample every 3,000 years, which gives us an idea that it's pretty well constrained. In addition to this, we also report the median resolution of the core. In this case, these people counted 1 pollen sample every 566 years. So that gives us an idea of what kind of questions we can answer with this pollen record. And also, we report all the publications where these associated to these. Just another example, this is a charcoal record from Slough Creek Pond. Again, we provide basic information about the site and the core, geographic information, including latitude, longitude, and elevation, data type, charcoal in this case, which is a proxy of biomass burning or fire. In this case, the parameters measured were macro charcoal accumulation rates. Macro charcoal refers to large particles of charcoal which are supposed to represent local biomass burning. Again, the name of the person who submitted the information. In this case, these data are not available in any other database. Same information. And here we can see, we can access the data themselves. Here's a charcoal record. So here we are looking at charcoal accumulation rate as a function of time. And what we can see is that there was not much biomass burning between 15,000 years ago and approximately 13. Then fires became more frequent. decreased again around 10,000 years ago to increase at approximately 9,000 years ago, where there was quite a lot of biomass burning until 4,000 years ago. Fire activity decreased then and remained low until present. As in the previous case, these data are available as a PDF or also the raw data for meta-analysis. Charcoal data are obtained in a similar manner as pollen data, that is, they come from lake cores, and we need chronologies for these sites. That is, we need to submit radiocarbon dates. We can access that information. These authors submitted 1, 2, 3, 4, 5, 6 dates, developed their chronology meaning an age depth model, which is available in the data set, in the database, as well as calibrated ages for the site and a calibrated age depth model. So we have this kind of information for every single record in the database. I'm not going to go over all the examples. I would be more than happy to do it if you guys have any questions. And in addition to this, if we look at the type of data that were collected for each of these proxies, we see that even though some were measuring the physical properties of the core, such as optical luminescence or electric conductivity, some other records depend on biological information. That is in the case of vertebrate fossils or tree rings or pollen or plant tobacco fossils. In those cases, we also collected the species that were present in each record. So 1,100 records have information about species presence and or abundance at each site, and therefore we have information about 275 species, which are grouped into 140 genera, 150 families, and 60 orders. This allows searching the database for species. Say we're interested in whitebark pine, we can search for whitebark pine, and we are going to end up with all the sites. That's going to be tree rings, pollen records, plant macrofossil records, which contain the word whitebark pine. Or we could be interested in the order Ungulata, for instance. We can search for that, and we are going to find all the fossil records which contain species that belong to the order Ungulata. So we thought that was quite an interesting tool for ecologists. So as we were saying, we can search the database either by looking at the map that we showed at the beginning, or by site, state, elevation. In case we're interested in high elevation vegetation, we can just constrain elevations and we are going to obtain the data sets above or below a given elevation. Data type, in case we wanted charcoal data. Proxy of, we could be interested in proxies of precipitation, and then we would end up with tree room records and ODL possibly. Modern vegetation type, in case we wanted to know the evolution of forests, we could just type in forest and we would end up with all the sites that are presently located in forests, authors, record lengths, and so forth. In addition, we can combine search words just to get to more specific data sets. So if we are interested in the history of pines in Colorado, we might want to search for proxies of vegetation with the genus Pinus and state of Colorado, and we are going to end up with that kind of information. So the idea is to make the information easy to access, easy to find, and then easy to manipulate. So in order to do that, we have assigned a specific name to each data set, specific number to each sample, and that allows, for those of you who are familiar with coding, that allows accessing not only individual sites, but also individual samples within each record, And that's pretty easy for, that makes things pretty easy for meta-analysis.
Well, I wonder if I can talk a little bit about what we know about history of whitebark pine now, or maybe we could take some questions now on the database itself.
I guess a question from, this is Dennis, and question I have is, looking at this really rich data set, how much, I guess, synthesis analysis has been done yet to look at the different data types and seeing whether there's consistency in the message or the type of climate information captured in these data sets, or are there inconsistencies between them that pose interesting questions about, I guess, the utility of some of these proxies. I guess, and the second question is, how much have you guys come up with the climate reconstruction using this suite of data yet, or is that something that is emerging still or being developed?
Well, some of this has been done, you know, over the long term, just in people that are interested in climate history, but interrogating the data set by bringing all these data types together has not been done yet, because just getting the data together and getting them in a format that they're accessible and you know, really looking closely at the chronologies has been a full-time job. You know, it's been a lot of work. So we're sort of, I guess, at the stage of actually saying, okay, let's look at all these proxy and bore in on particular questions in particular time periods. Now, having said that, like I said, there are paleoclimate records or paleoclimate reconstructions for the region that have already been published, but we haven't gone after them with a sort of keen eye that's possible with this data set.
Yeah, because it'd be nice to cross-compare those and see, you know, are we getting a different picture with greater resolution and things like that? So some interesting questions come up.
Yeah, absolutely. There are interesting questions, and I mean, there's certain time periods we could focus in on, like the medieval climate anomaly, which is about 1,000 years ago, and really see what the records are for that time period, which is when a lot of probably, you know, some of the living trees were established or being stressed during that period, or the little ice age or something like that.
Yeah, that type of analysis might be a good Powell Center type activity. Getting a group together would, you know, talk to Jill about that. Yeah,
that's an idea.
Yeah, something that I think would be quite interesting is measuring uncertainties. Because you get one tree-ring reconstruction and you get a picture of precipitation. You get two and you have an idea of precipitation in the region. You put 300 together and you're going to start talking about uncertainties and what we really know and what we can learn, and especially what we cannot know. So I think that would be quite valuable.
Yeah. This is Joe Barsugli. I second Dennis's idea of working towards the idea of bringing in some of the climate reconstructions in a way that can be compared with this. Because you have tree rings, but I don't think last time I looked that you had the actual reconstructions of precipitation or stream flow in the database.
No, we have the raw data.
Yeah, and so there's been a rich literature and actually a database, you know, tree flow that Western Water Assessment and others in Arizona and Pinus have worked to build on tree ring reconstructions. So I'm wondering, you know, thinking down the road, I mean, obviously it's a great sign that we're all excited about where you can go with this, but you know, that it would save a lot of work because they already have a good database interface that you could link to from this. But that said, what Dennis was suggesting is really interesting. Is we have climate reconstructions based on one proxy. There are some multi-proxy reconstructions, but they tend to be larger scale. And now you have all this in paleoenvironment data to connect with it. So I think that's at least having links to these other resources might be a useful
We probably have
adjunct to this.
We probably have the tree ring data that was used for the climate reconstructions a year or two in here. So, but we don't have those particular climate reconstructions. We just have the data that led to it. So yeah, I think there's a lot of opportunity, and it's really been valuable. There's an international effort to look at the last 2,000 years that's brought proxy data of all kinds together to try to understand climate variability on that time scale. And now we have all the data together in one place for the north central region.
Yeah, so I think maybe collecting some links to those efforts just on the website would be really useful.
Mm-hmm.
You know, just not doing not integrating all the information, but at least saying, climate reconstructions that you might want to go to that compare to this, so that it would be kind of a one-stop, one center to go to if you wanted to do the kind of analysis Dennis was talking about. Because tree flow has great reconstructions of stream flow, although not so much up that far north, although they're getting there. And as I know, the Ocean 2K project has a lot of stuff of reconstructions of El Nino and things like that. All sorts of ocean proxies. So, yeah.
Dennis, is that what you were thinking of too, Dennis?
Yeah, just trying to connect these diverse, disparate bits of information, and also then looking at, are they getting the same message across these different proxies? And I think the stuff with pages that you were talking about, and I think the work, I think this is really ripe for a Powell Center working group, and Jill has funding for a postdoc, I think, or some research, part-time research associate, so that might actually fit in quite well with where you guys are headed.
Yeah, those are due at the end of April. But you have enough time to put together a proposal if there's interested in doing that. Mm-hmm. In the interest of time, why don't we let Cathy go on and finish this presentation, because I do want to go through the 3 foundational areas and the 3 funded projects just to kind of check in a month of thing and try to wrap up by 12. So why don't we hand it back to Cathy.
Okay, well, this is work that we're just starting with Andy Hansen. I know Andy's on the line. And it's really looking at the history of whitebark pine in particular in the greater Yellowstone. And so for us, working on the history involves going to a bunch of these data sets, and one of them is pollen, looking at, we can't pick out whitebark pine per se, but we can pick out the 5-needle pines as a distinctive pollen type. The other, so it's a matter of going to studies where they've separated out white pines. We also, there's some work identifying the presence of whitebark pine based on little fragments of needles in some of the sediment cores. In that case, you're looking at plant morphology. And then there's studies from the tree ring community looking at growth patterns of whitebark pine. So whitebark pine is sometimes used as a paleoclimate proxy to do some of these climate reconstructions that Joe was referring to, but more often it's not. More often it's been used to just look at growth response, looking at the ring width pattern. And so that's a lot of work that like Dana Perkins has done and Tom Swetnam. Whitebark pine tends to be a high elevation tree. This is from Yellowstone, a vegetation cross-section, but it also grows actually at a variety of lower elevations as well. And so our focus has been trying to understand the highest elevation where it can be the forest dominance, just growing at tree line or and just above subalpine forest. Another bit of paleo data is fossil wood. So there's a bunch of these remnant wood records around the west and around Yellowstone area. So for example, in Yellowstone, we have wood that dates back 1,000 years to this medieval climate period. So it's in tundra vegetation today, so we know that whitebark pine had a higher upper elevation range. There's also wood that dates to 6,000 to 10,000 years ago, which was another warm period when the range of whitebark pine was higher than it is today. And so you can take a pollen record. So this is in the database. This is from a site in Yellowstone. And you can see the sorts of things that Virginia talked about, particularly this trade-off from, from sagebrush and grass sometime around 12,000 years ago. Those pollen types drop off and they're replaced by pine. There's kind of an intermediate period of spruce and fir. But what we see is that whitebark pine really had its heyday in the early period of Yellowstone, that it was really an early colonizer following glaciation, came in and was a dominant tree in a way that you don't see as the climate gets warmer and warmer. At least at this site, it tends to be restricted, and probably the vegetation type shifted to an elevation above this site. And you can look at multiple sites to try to understand what's happening with whitebark pine or any of the vegetation. So, for example, here's 3 sites in Yellowstone, and you can take these pollen data and start to assemble them to really work out a paleo vegetation history. So the 3 sites are Daly Lake, Blacktail Pond, and Slough Creek Pond. As Virginia explained, we can plot the history by time because of the way we take radiocarbon dates and convert them into calendar years for these different cores. And then you can see what's happening at different sites and trace the pattern of movement. So you can see when you take these 3 sites what happened as glaciers retreated. From a climate point of view, this is a really important time because it's also a time when the climate went really rapidly, warmed about 5 to 10 degrees centigrade, which is, you know, the range of time that we think about, the magnitude of climate change that we think about for the future. And you can see it going from tundra to parkland. Then you can see the arrival of whitebark pine and so on up towards. This diagram stops 8,000 years ago when Douglas fir comes in. Virginia's been playing around with the database and just looking at whitebark pine. And so here she's taken 4 sites, different latitudes and longitudes within the greater Yellowstone area, and she's plotted so those are shown as blue dots in each of these graphs by latitude and longitude, and she's plotted the blue dots to show you where they are. And then the shaded area is the sort of pollen abundance of whitebark pine at different time periods. So you can see, for example, in that early glacial period from 16,000 to 12,000, there's a lot of whitebark pine. Well, a lot. You get up to 4% of the pollen. And then you can see that as you go to 12,000 to 8,000 years ago, it's declining, but it's still present in Yellowstone and some of the areas in the Wind Rivers. And then 8,000, it's really becoming more abundant in Yellowstone. And 4,000 to present, it's not very abundant at all, really. And so our understanding of whitebark pine, we understand that it survived in the Yellowstone region through the last glaciation, so it's a pretty tough species. It was never abundant, but it was probably present in refugial populations based on pollen data. We think it really was happiest in the late glacial when there was not a lot of competition from other trees. The climate was warming really rapidly, and there was a lot of very mineralogenic soil around, and it was present at all elevations. And then we can see that its distribution became really restricted during previous warm periods, like the medieval climate anomaly and the early Holocene, when you see it growing to higher elevations, but it's pretty much lost at the lower elevations. And the other thing we're getting is that this is a very rapid response ecologically. It's really helpful, I think, to look at that in terms of what's projected for the future. And then what I'm not going to go into is that it's very sensitive to past changes in fire activity, and also there's some relationships that you can see between whitebark pine and past beetle outbreaks. So that's the sort of data. I'll stop there, but that's the sort of data that we can marshal together by looking, at these data sets. So I think it's going to, hopefully it's going to be a good resource for people looking at ecological response to species and communities at present.
Yeah, I think that's really a neat example of bringing the database to a specific project. So that's neat to see.
This is Andy. Could I ask a question, Cathy?
Sure.
It's quite interesting, your data and comments about the how much it liked the post-glacial period. Looking at the present-day distribution, we find this species up in the coldest places, but think that it's partially due to competition with other species. Presumably, the pollen data would suggest that it colonized those post-glacial areas in the absence of the current competitors, in the absence of Doug fir and lodgepole and so forth, suggesting, in fact, that it really does well in those cold environments?
I think that's right. I don't think it's completely a competition story because it's really there before lodgepole or Doug fir arrive, and it's doing really well. It moves into a really open landscape with only spruce being present as a kind of a spruce parkland, and then you see whitebark pine coming in, and then lodgepole pine and Douglas fir arrive later.
And is it do you find it in any kind of warmer settings during that time, or maybe those just didn't exist?
The climate in general is warming pretty rapidly, especially summers are getting warmer, winters are getting colder at that time. But there may have been conditions that were as warm as present in the summer, but not in the winter. So there's a bit more seasonality then than there is today.
Okay, well, good, thanks.
So let me add, and Andy, glad you're on the phone and appreciate this presentation from Virginia and Cathy. The interesting thing to me is to say how, with the Whitebark Pine Project, having specific managers involved and management options for current activities with whitebark pine and preservation or promoting it, how do you think that this kind of can temper those management actions or inform those management actions? I think it's relevant to, we can pick the handful of species that the Southwest Colorado Project would be using and think about the same same question that they could explore. But since you guys are both, since Cathy's working on the analysis and Andy's and Cathy are both involved with the managers, what do you think the kind of take-home message would be for them in kind of for current management activities?
Well, maybe I'll start from a paleo point of view and then Andy can answer. The paleo gives you this context of sensitivity to the past. So, as we move into warm conditions, we can see that really shifts the range of whitebark pine. So there's the paleo, we can point to the paleo as an example of that. And as I said, we also have some insights about the sensitivity to fire in whitebark pine that's interesting. I also, for me, I think about history a lot, but I think it's really interesting to know that whitebark pine has been here through the entire 15,000 years ago. And there were times in the past when it was way more abundant than it is now. But it has survived through other past warm periods, and I think that needs to be on the table, too, in thinking about its vulnerability in the future.
Yeah, just to second that, we had a workshop with our research team, including the management colleagues, where Virginia and Cathy presented their approach and some of their initial data. And there was a lot of interest among the managers in this notion that that this might be a species that can persist through periods when the climate is, quote, not suitable, just because it's able to stay alive even if it's not reproducing or not expanding. And they took I guess they're very interested in learning more about that. In the case of whitebark, any kind of suggestion that it's not all going to disappear in Greater Yellowstone in the coming century, is of great interest to the managers. I think they feel like they can motivate management strategies when there's a hope of success, and so they would like a balanced analysis to see what extent there might be a hope of success.
Yeah, it's interesting when you look at like the 8.5 projections for the future. I mean, then it's like nothing survives. They're so dramatic, and it's not very hopeful to a manager, although it may be reality. But some of the, more moderate scenarios, then maybe there's opportunity, or we should be thinking about the ecosystem differently.
But I think you have to incorporate multiple stresses under this contemporary environmental situation where not only do you have climate changes taking place, but then you have increases in CO2 levels, you have nitrogen deposition, you have landscape modifications, fragmentation, which sort of really alters the equation of how species in the past have resided in refugia and now maybe more challenged and constrained by their ability to exist.
Yeah, I think that's right. I think the devil's in the details, and I mean, it's a big research agenda globally to try to understand what the relative impact of those different drivers is. Especially at high elevations, I think that's a really interesting question.
Do we have time for one more question?
Sure.
This is Renee, and Virginia and Cathy. Jeff mentioned we're working on the Southwest Colorado climate adaptation project, and I would be very interested in getting some information on some of the conifers, especially in the San Juan and Gunnison Basin, so Southwest Colorado, region. How would I go about doing that? Would I just contact you, or I'd be very interested in that.
Yeah, we can show you what's in the database, so maybe contact us and we can work with you directly on that.
Okay. And is the database online? I didn't pick up on, I missed the first part, so.
It is going to be online through in the long run as part of through the portal of the Institute on Ecosystems here at Montana State, but there'll be an online version that's sort of searchable and start with a map and that kind of thing that'll be available as a link on the IOE page sooner. We're still a little unclear as to what should happen to this database from the CSC point of view. But Renee, we can help you directly, so.
Okay, perfect. Thank you.
That's to answer your question, yeah.
Thank you very much.
I think having it hosted at Montana State University is fine. From our perspective, we might think about a redundant copy or something like that we could put on a USGS server, but you leave it to you guys for posting and showing it. We could take that offline, I think, and I guess I would ask Renee and Cathy to maybe CC me and Joe Barsugli. I think Joe's probably kind of interested in tracking, and I certainly am, to kind of see how it unfolds, because it's neat to see the leverage between the projects.
Okay. Sure.
Yeah, I would think now is the time to see how this can be applied in more than one project. So putting it in the Southwest, seeing if it can inform the Southwest, and trying to brainstorm ideas and maybe get some grant money to push this out there in other ways. I mean, as you said, it's not particularly useful for someone who doesn't know what the species names are on the pollen plots or how to interpret them. But I mean, there are park biologists. There's all sorts of people out there, and at the managerial level, who have the ability with some small amount of training to at least interpret some of these for all sorts of purposes. So I just would like to see this used. It's really a tremendous resource.
Great. Yeah. Yeah. No, we would too. So.
Well, I mean, even just breaking up what Virginia did today into a couple of YouTube videos, chronologies, proxies, basic use of the database, advanced search, you would have some sort of tutorial.
Yeah.
So.
Great idea.
Yeah, I just was brainstorming as you were doing it, and I'm thinking, Virginia's presentation was really very easy to listen to, and so.
Well, we are recording it as a first
Pardon
round. We are recording it so that we could point people to the. In the sake of trying to respect people's time to wrap up in an hour, we did want to have some just kind of administrative sort of checking in. I think the 3 foundational science areas are moving forward, staying in touch with various the email lists or communicating that way. We heard from Andy and Cathy on that project. I don't think anyone from the surrogate species in the plains and prairie pothole region is online. Oh.
I actually, this is Helen. I'm actually here.
Great. Thanks. Didn't notice your name on that list there, so.
I saw you, Helen.
Yeah. Good. So I would. Yeah.
I must say though, I won't say that I've done too much since we spoke last. I had 9 weeks of maternity leave, so I just got back last week. So
I think as we move to these monthly calls, it's not so much that people have to report what they've really done since the last meeting. I think the idea would be if there's a meeting that other groups, especially the foundational science areas, should be aware of with the 3 projects or vice versa, this would be our time to kind of say that. And Joe, maybe just an update on, were you able to advertise a hire and bring a postdoc in? I knew you were kind of in the process of that the last time we talked.
Well, we're advertising as we speak. It's going out. There was some delay for various reasons. But yeah, that's sent over to Series, and they are posting it once they get the money came here in December, and I was out with vacation and bronchitis for the better part of a month. So vacation before the bronchitis, so that was good. But that's happening. I will send that around to the University Consortium list, the advertisements, because I want to put this out widely. And the other thing I wanted to mention, something we should mention for the University Consortium, is that there was a project here that wrote a proposal, and the Climate Science Center, because it dovetailed so well with what they were doing, was able to write a letter of support. So that's something that the University Consortium can take advantage of if they're writing proposals that really fit into the revamp program, that really fit into some of the projects that are outlined in the science, that a letter of support is something that can be added. And I don't want that only to be for my friends who were down the hall here, but really anybody in the University Consortium who can justify that this is good. So that said, that is our update, I think.
Thanks.
A comment that, this is Dennis, it's not related to the adaptation effort, but just a heads up. This is a theme we're picking up some steam on, is this Open Science Conference for fall of 2014. We have a group now on staff to help organize that, and we'll probably be putting out calls or at least a heads up on this. It's probably going to be November 2014. Still working out details on that. So things will be happening rapidly in the next weeks to months.
The topic?
This is Rudy. Can you give us a 90-second overview of what you're talking about?
So we're trying to get a conference of researchers doing climate change research and natural resources. Sort of that's the broad theme of it. Get people together to share what they've done, and sort of highlight some of the research that we've sponsored and funded through the Climate Science Center, and probably work with some of the LCCs as well to see, how can we better leverage, better understand what's been done, leverage connections between various projects, developing that sort of network of research activities, and also with managers who are looking for research information, getting connections between management issues and research activities related to climate change and natural resources in the region, and then sort of engaging young scientists more directly into the activities of the Climate Science Center, really building on the type of activities that we have ongoing, and looking into the future, kind of trying to help this community define what directions and what research activities need to be done, and seeing how we actually leverage and better integrate and coordinate things across various universities, USGS centers, and other sort of research groups within the region.
Is it North Central only?
Yes.
Okay.
Say, Dennis, Andy here. The World Parks Congress is in November 14. I don't know what dates, but it would be nice if they didn't conflict, these two important meetings.
If you could send me the dates, and then we will try and make that happen. Not happen, whatever.
So I think I'm sharing should be do people see the kind of the memo that Geneva had sent out? There might be multiple on the WebEx.
We see something that's test fish-off approach to quantify individuals' tracking of
Bringing it.
Jeff, are you trying to show the revamped schedule?
Yeah. Does it show now?
Well, we can just read it off to you, I guess.
Yeah. But just then, let's. While I'm trying to do this, I think I can. But is there any other, especially meetings that folks need to know that we want to share across projects that people should be aware of? Okay, so are people seeing? What do you see online? Is it?
we see your calendar.
Now, do you see?
North Central Climate Center's monthly check-in.
Okay, no one else does, and no one in the room does. But anyway, Geneva had sent out a list, and so we just had this as our kickoff. And again, thanks to Virginia and Cathy for being the inaugural talk with this idea of having some science related to, and then the check-in on what's going on. Have one scheduled for February 25th. Joe, I think that you were going to try to find a colleague. I think you mentioned someone specifically working on dust on warm snow.
Well, I mean, I was on that paper, but I think Jeff Deems would be maybe a better speaker on that. Although I could certainly do it since I know the work. And I was trying to contact him, but I'm not sure whether he's going to be in the field then. So one of us can talk about it.
Okay.
And it's just some work. Relevant to the Southwest group particularly, but also relevant to the entire area. So.
And March 25th being the Climate Change Adaptation Framework for Southwest Colorado. From that project, Karina is set to do that talk. We do have the 5th Tuesday, so a little bit of an exception because we have the training on the 4th Tuesday, but April 29th will be the dry concept, and Shannon presenting that. I'm excited that John Sam's product should be available by May to see his regional climate model, which I think is going to be an interesting data set for us to explore. That is a regionally or dynamically downscaled regional WRF-based regional climate model for the Missouri River Basin that I think should be available to the 3 projects in the region to consider. And we'll have Joe Barsugli's kind of stamp of, I don't know if it's approval, but caveats. Maybe we'll look for Joe in the climate area to do that. And then June 24th, we're hoping to have a communication plan, and we thought we would present that, whether that's a half-hour presentation or maybe there's something more with that meeting. But you know, maybe that communication plan could communicate some of the other stuff we're doing in what we're calling capacity building. Some of these smaller projects on phenological observations with webcams, the NASA developed students, and the tribal indigenous geographies phenology network. So you know, maybe we'll mix that communication plan and actually communicate some of these smaller projects. So that's the outline, and we're at about an hour, so I don't know if there's anything people want to throw out or questions. Okay, sounds like we're all set. And again, thanks to Cathy and Virginia, and we'll look forward to hearing from Joe next month, and appreciate the time, everyone.
Great.
Thanks.
Thank you.
Bye-bye.
Bye-bye.
Thank you. Bye-bye.